binomial products. Bi, of course, the prefix meaning two. Nomial, terms. Hence the term, as we've seen before, trinomial, three terms, polynomial, many terms, and so on. So we're talking about things with two terms, and we want to multiply them together. So each of those things has two terms. Now, there's all sorts of different ways of remembering how to do this. I think probably the most common one is what they call the FOIL method. You know, first, outside, inside, last. I was taught a thing called the FACE method. You ever seen the FACE method? Oh, watch this, you'll love it. You actually draw in. So you're still doing first, outside, inside, last. So first is the x times the x. The outside would be the x times the 1, and the inside the 6 times the x. And then the last, 6 times 1, look, you know, you've got a face. You see, so you get there's the chin, there's the mouth, those parentheses become the nose, those are the ears, there's the bump of the... Oh, well, I liked it. Okay, so let's add like terms together and we get our final answer, x squared plus 7x plus 6. Okay, but of course, maths, as I mentioned to you yesterday, is all about finding patterns to make life easier. Because if we're going to do that same process every single time on things, well, we can save that by creating a formula. It's basically what a formula is. You find a pattern, then you use a formula to do it rather than going through the whole process each time. And we have these special binomial products, the a plus b all squared. You may remember that when you expand it out, it always becomes a squared plus 2ab plus b squared. The interesting thing, I don't know whether you've ever seen this before or not, that's just with two terms. That formula works. It doesn't matter how many terms you got there. So if I had a plus b plus c all squared, it would be a squared plus b squared plus c squared, but then twice all the pairings. So 2ab, 2ac, 2bc. If it was a plus b plus c plus d all squared, you'd have a squared, b squared, c squared, d squared. See if I remember them all. 2ab, 2ac, 2ad, 2bc, 2bd, and 2cd, and so on. So that pattern is true for all of them, regardless of how many are in there. With the negative one, again, it is true. You just got to be careful on the negatives. We'll match it. So because the negative was with the b, whenever you multiply it with a positive term, you'd end up with a negative. So when you're doing the pairings, you just see, oh, well, what were the signs in front of the two pronumerals as to whether it'll be positive or negative. The squares, of course, are always positive. And the other one that we have that's quite common is our difference of two squares. So it doesn't matter the order they are around. If you see the sum of two pronumerals and the difference of two pronumerals multiplied together, we know that'll give the difference of two squares. So a squared minus b squared. And that can save us a lot of time. So all right, here we go. X plus 2 all squared, we now go, oh yeah, I know that one. Now, I'm not saying you would write that out. Certainly at this stage, I think most of us would probably just write the final answer. But in our head, this is what we're thinking. Okay, first term squared, twice the product, and the last one squared. But most of us now just write it down. We know there's our answer. That's the whole point of the formula, to save us that time. X squared plus 4x plus 4. The only thing really to be careful with is, of course, twice the product. Sometimes we forget to multiply by 2. So 3x minus 4 all squared, we'd just go, bang, that's our answer. The first one squared, twice the product, last one squared, there's our answer. Difference of two squares, okay, first one squared minus the second one squared. And just by having those little formulas, that pattern that was created, again, this just saves us a lot of time. Here's a binomial times a trinomial. The only thing we've got to be careful here is to make sure we get the right number of terms in the answer. If I've got 2 terms multiplied by 3 terms, then when I expand out, before I simplify everything, then I am expecting 6 terms. So it's a way of keeping check on myself. Have I done all the multiplications? So I tend to do it systematically. I say, okay, well, let's multiply A by everything, and then I'll multiply 2 by everything, and we'll come up with our answer. And all right, collect like terms. There's my final answer. Okay. Alrighty, so just a little quick one for today. 1B, some questions on binomials.